Now, I might have to finish a little early today. I have some errands to run, it turns out. And because of that, I might be a little bit slower in getting the video out also. So apologize about that. So I might have to stop maybe 10 minutes to, 5 minutes to, something like that. So we'll see how it goes. All right, let's see. The quiz is now too late. So here's the quiz. All right, so you just plug in the numbers. So -1, -0.01, -0.001, 0.9576, 0.995, 0.9995, and 0.1, 0.01, 0.001, 1.0517, 1.005. Okay, it gets very close to 1. So the guess is the limit as x equals to 0 if e to the x minus 1 over x is equal to 1. Second one, you're only approaching from the right side. So these are the numbers to plug in. 31, 301, 3001, 30,000. It just shoots up like crazy. So the limit is infinity. And that's that for the quiz. Okay. So straight plug in for that. Okay, so we are here. We're still on par to have an exam this coming Friday, second test. Now that you've had the first test, you know, they're all going to be similar. So you turn in the homework Friday, right? And what do I turn in, you ask? All of this. 2.4 skip altogether. I decided to throw that out completely and a few other changes here. Okay, and just like the previous exam, you can have one cheat sheet. So 8.5 by 11, sheet like this. Front and back, put anything you want, and a calculator. But other than that, no other books or notes or calculators. You can't have anybody help each other. Show your camera with the natural background. Don't have a special background like, you know, the Golden Gate Bridge or something like that. It's got to be your actual background. And a little bit after 12, 12:01, 12:02, I will email you or send you Canvas announcements, the exam, but I'll also show it over here for those of you who like that better. And during the test, you show your camera, mute yourselves. If you have a question, just unmute. Sorry, don't unmute, but ask in the chat. Okay. And then class will end as usual at 1 o'clock. Then you have 5 minutes to take a picture. So, you know, click, 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 take a picture or use a scanner like cam scanner. And then that has to be by 1:05. And then you have until 1:30 to submit the homework, although if you want to submit it earlier that day, you're allowed to do that. Okay. All right, so it's mostly the derivative today, 2.7 and 2.8. I do want to go back and finish up the last part of 2.6 on the squeeze theorem. So the squeeze theorem back on page 101, section 2.3. Here's the squeeze theorem. Okay, so you have three functions, f, g, and h. F of x less than or equal to g of x less than or equal to h of x. So here's the picture, figure 7. You got f less than or equal to g less than or equal to h. Okay, so lowest, in between, highest. The limit as x approaches a of f of x is L. The limit as x approaches a of h of x is L. That means the two extreme functions. Okay, the lowest and the highest function both have the same limit. Okay, so the two-sided limit as x approaches a for both the blue and the green, the most extreme functions, the lowest function and the highest function, both approach the same limit, L. G of x is stuck between the two. Then the conclusion by the squeeze theorem as to the limit as x approaches a of g of x is also equal to L. Okay, so the squeeze theorem is sometimes called the sandwich theorem. G is stuck, it's sandwiched between two functions which both approach the same limit, L. So therefore, this function also has to approach L, the in-between one. Okay, so the lowest function approaches L, the upper function approaches L. Any function that's stuck between the two will also have to approach the same limit. Okay, so that's what that's doing. And so let me just clean that up again real quickly. So use the squeeze theorem to find the limit as x approaches infinity of sine x over x. So what I was showing with you last Friday was this. We know this is true from trig, right? Sine of x is stuck between -1 and 1. Divide everything by x. X is a positive quantity because x approaches infinity, so I don't have to change the inequality symbol. So sine x over x is stuck between -1 over x and 1 over x. Okay, the smallest function, -1 over x, approaches 0 as x approaches infinity. The biggest function, limit as x approaches positive infinity of 1 over x, is also 0. Okay. If I plug in a billion, -1 over a billion is almost nothing. Positive 1 over a billion is also like nothing. So therefore, by the Squeeze Theorem, limit as x approaches infinity of the in-between function, sin x over x, is equal to 0. Okay. So that's that, and I wanted to show you quickly the graph. Do you remember the graph of 1 over x? And therefore, -1 over x would just be the reflection across the x-axis of it. Okay, so let me show you this, the graphs. Okay, here's 1 over x. We know there's another branch over here, but it says x approaches infinity. Here's -1 over x. Okay, and sine x over x, I have that very crudely in red here. It's stuck between -1 over x and 1 over x. Since there's a sign involved, it kind of bounces up and down like a sine function would, but it stays between 1 over x and -1 over x. So as x gets really, really big, the lower function approaches 0, the upper function approaches 0. So something in between, like sine x over x, it bounces up and down, it would also approach 0. Okay. So that's it for that one for the Squeeze Theorem. And now I'm ready to start 2.7 and 2.8 on the derivative, which is all we have between now and Thursday. So the next 4 days will just be derivatives, derivatives, and more derivatives. And you have to do it by the limit definition, as we said. Okay, so no shortcuts. Those of you who know shortcuts, I will not accept it. Okay, you have to do it by the limit definition, which I will share with you again. The best definition to use is this one on page 152. So to find a derivative, f prime of x is the way we say it. F apostrophe x, f prime of x, limit h approaches 0, f of x plus h minus f of x all over h. Okay, so again, those of you with some background in calculus, you must use this limit definition. Of course, those of you that don't have any background in calculus, you don't have a choice. You don't know anything else. You have to use this. Okay. Now, if you happen to know shortcuts, you can use that as a double check, but you must show me this. Okay, I will not accept it. And Prasanna, I know Prasanna's here. When Prasanna has review outings with you guys, okay, I'll tell Prasanna, don't accept any shortcuts. All derivatives have to be done this way. For now, limit h approaches 0, f of x plus h minus f of x all over h. Okay, so when you do any review sessions with Prasanna also, he's going to make sure that you know how to do this, not the shortcuts. When we get to chapter 3 is all about shortcuts. Okay, but we're not there yet. Okay, so for right now, everybody use this thing for the derivative. Okay, those of you who don't have any background in calculus, you say, you know, I don't know what you're talking about, the shortcuts. That's fine. We're not supposed to know the shortcuts. All right, so we're only going to do this. Okay, a little bit of background where this comes from, and then we'll start doing some derivatives. Okay, they can get quite messy. I mean, the whole idea is you see how messy they are, and you say to yourself, boy, I sure wish there were some shortcuts for this. And yes, that's the next chapter. Okay, all right. So background for the concept of the derivative. All right, so here's a graph. The green is supposed to represent some graph. Okay. Here's x comma f of x, very generic point, x comma f of x. Here's another point on the graph. So if I connect 2 points on the graph, technically that's called a secant line. Okay, so here it is. It almost looks like a tangent line if the 2 points are close. So I move to the right a distance h. So if this is x and I move h, it's going to be x plus h. All right, so this is x plus h comma f of x plus h. Okay, so the ordered pair is x comma f of x plus h comma f of x plus h. Okay. What is the slope m of the secant line? Well, it's y2 minus y1 divided by x2 minus x1. So here we go. F of x plus h minus f of x, there it is, y2 minus y1, divided by x2 minus x1 x plus h minus x. Now, you can't do anything with the top, but you can do something with the bottom. X plus h minus x is just h. So the slope of the secant line is f of x plus h minus f of x all over h. Okay. Now, we move this point closer and closer and closer and closer to x, just like that 2.1 picture I showed you. We know now how to say that formally. That is the limit as h approaches 0. So moving this point closer and closer and closer to this point, we can now say that's what happens when we take the limit as h approaches 0. So the slope of the tangent line, m tangent, is this expression, but take the limit as h approaches 0. So limit as h approaches 0 of f of x plus h minus f of x all over h. That is our definition of the derivative. And frankly, if we were meeting in class face-to-face, I would make you guys memorize this. But since you can put it on your cheat sheet, I'm not making you memorize it. So you can just put this directly on the formula sheet for the definition of the derivative. All right, so here is our definition of the derivative. It was exactly the same as what I have here, so you don't have to write this down if you don't want to. Definition of derivative on page 152. But here it is again. It's being recorded so you can see it again if you wish. So formal definition of derivative. The derivative of f of x is f prime of x. The way you say it is f prime of x. You put an apostrophe, and it's equal to this mess here. Limit h approaches 0 of f of x plus h minus f of x all over h. Okay. And today I'll show you some examples of this. It can get quite messy. As you might expect, the messiest part is this. Well, h is not messy at all. F of x, well, it could be messy, but at least f of x is just the original function. Here you just copy the original. What students will have the hardest time with is this part, f of x plus h. And again, I'll hasten to add, there are many more definitions of the derivative. If you look at 2.7 and 2.8, you might see other definitions of the derivative. Saying, what's all this? And they seem to give us 3 or 4 different definitions. Mr. Stewart is correct. They're all correct. But why give you so many definitions when you can survive with just one? And this is the main definition that's often used for the derivative. Okay? It's a limit. And you notice we've done a lot of limits already. And nice thing, all these limits are as h approaches 0. And you might say, oh, good. Can I just plug in? No. You'll never be able to plug in. How come? Because if you plug in, you got a 0 in the bottom. Okay, so for all these limits, almost without exception, you have to do some algebra to hopefully cancel out that h. Once you can cancel that h, then you will be able to plug in h equals 0. Okay? So that's what's happening now. So we'll just get our feet wet and do some derivatives. Frankly, they can get really messy, get pretty nasty. And you say to yourself, boy, wouldn't it be nice to have a shortcut? And that's the whole idea. You learn the long cut by the definition, and then hopefully later on you appreciate the shortcut after doing a whole bunch of long cuts, so to speak. All right, so here we go. Now, the language in the problems might be like so. Okay. 148, 2.7. Find the equation of the tangent line to the curve at the given point. That means derivative. Okay, find the equation of the tangent line. And yeah, just in case, in case there's some of you that don't ever plan on getting the book. So yeah, let me project these. So page 148, homework problems, there's 2.7, please, up to about 5-ish, a little bit more. Okay, there's the rest of that. And on the next page, 149, that's up to about 25 or so. A little bit more. Okay, and the next page. Not sure we have to do these, but I'll show it to you anyway. And yeah, I'm sure we don't have any of those. And any of those. Okay. And 2.8. 2.8, page 160. 161, a lot more pictures here. More. more. Okay, next page. 162. Some more. We'll be doing a lot of these. Find the derivative using definition. Some more. Some more here. Whoops. There. There. Okay. Let's see. Maybe the next page. Yeah, no, we don't have any of those. Maybe some of these. Not sure, but I'll show it to you. Here. Here. Okay. All right, so let's get ready to do some derivatives. So 2.7, y equals square root of x at the point 1, 1. Okay, do you remember what the square root function looks like? All right, looks sort of like that. Square root function. You're at the point 1, 1. Okay, I'll go ahead and show you something. Square root function looks sort of like that, right? There's 1, 1. So the tangent line would be something like this. We're asking what's the equation of the tangent line. All right, so here we go. First, I find f prime of x. Limit h approaches 0 of f of x plus h minus f of x all over h. All the problems work this way. Well, they might give us a different letter, like t, but it's the same thing as we use extra t. Okay, so limit h approaches 0. F of x plus h means square root of x plus h. Minus f of x is just the original function, square root of x, all over h. Okay, so I'm trying to find this limit. You can never do any of these by direct substitution, because if you plug in, you get 0 on the bottom. But we've played this game before. I can multiply by the conjugate of the numerator, which is why we spent all that time working problems like that. So multiply by radical x plus h plus radical x, right? We played that game before. So radical x plus h plus radical x, top and bottom. Again, so that way this looks like a minus b, a plus b. So what's a minus b, a plus b? That's a squared minus b squared. So the square root of x plus h squared just becomes x plus h. And the square root of x squared just becomes x. Okay? Don't multiply at the bottom. Usually you don't want to multiply at the denominator. Okay? And what do you notice? X minus x cancels out, leaving me with an h on top. And that h can cancel that h in the bottom. Very nice. That's what I want. So now the numerator is just 1. My denominator is all that. And side note, you might have missed that if you just had to distribute the h out and multiply that out. But the whole idea is don't multiply the h because I knew that was going to cancel with this h there. So now I have this. And please notice you keep writing lim until you're ready to plug in. Now I'm ready to plug in 0 for h. Don't plug it in for x. It goes in for h. So I have 1 over radical x plus radical x. Final answer is 1 over 2 radical x. So that's the derivative function. Notice it's a new function. So now if I want the derivative anywhere, I just plug in whatever they tell me to. So they tell me to plug in 1, x equals 1. Plug in 1. 1 over 2 radical 1 is 1/2. So the slope of the tangent line is 1/2. Right there. M is 1/2. If I want the slope somewhere else, like what's the slope at 4, I plug in 4. I have a rule. I have a rule that tells me the slope of the tangent line anywhere. So what's the slope of the tangent line when x is 1,000,000? I just plug in 1,000,000. Okay. So what the derivative gives you is the slope. So for the original function, original f of x, that gives you the y coordinate. F prime of x gives you the slope. Okay, now it asks for the equation of the tangent line. We will always just go right to the point slope form and then stop. Okay, so point slope form, y minus y1 equals m times x minus x1. I want you to leave your answer in that form from now on. right? So y minus y1 equals m times x minus x1. Some of you have kind of gotten by without it. Sorry, you can't get by with it anymore. You must write your answer like this. Okay, so y minus y1, my x1, y1 is 1, 1, equals 1/2 parentheses x minus 1. Stop. You may now leave your answer like that. Meaning, you know, I know, we can all do the simple algebra, make it look like y equals mx plus b. That was for your algebra 1 class. We're focusing on the calculus. And so normally once you get to this stage, unless I say otherwise, just stop. We'll actually have to go farther later. We'll actually have to do y equals mx plus b, finish the whole thing, but not yet. Right now, once you get to this, I say, okay, stop. Let's focus on the next problem. Okay. Okay, the next one I'm going to show you is way over in 33. As I said, I'm going to jump around here for reasons. Okay, so 33 gives you a fraction. Says find f prime of a. So what's a? It's just another letter. So I'll find f prime of t, and then just plug in a when I'm done. Okay. All right. So here's my original function. F of t equals 2t plus 1 over t plus 3. So yes, I'm using this formula, except instead of writing x plus h, I'm writing t plus h. And instead of f of x, I'm doing f of t, but it's the same thing. All right, limit h approaches 0. Okay, great big denominator, h. F of t is just the original. So I copy all of this stuff right here. 2t plus 1 over t plus 3. Now, the hard part, f of t plus h. That means right here, pretend you erase t, put parentheses, t plus h. Right here, erase the t, put t plus h. So it looks like this. 2 parentheses t plus h plus 1 over parentheses t plus h plus 3. So this is what I have right now. You say, how can I possibly clean up that mess? So here's what I'm going to do. I think we've seen this concept before. You have a fraction on top of a fraction, right? We don't like that. If we divide by a fraction, you multiply by its reciprocal. So instead of dividing by h, I will multiply by 1 over h. So this dividing by h is the same as this multiplication by 1 over h. Okay. It's the same thing. It just makes it look nicer. This looks pretty bad, right? Having fractions on top of fractions. This looks a little bit cleaner. Now, a little bit of cleanup of the algebra. That's 2t plus 2h plus 1 over t plus h plus 3. And that stays the same. Okay, so right now, I have this minus this. I need a common denominator. So the common denominator is just t plus h plus 3 times t plus 3. Okay, so what do? I multiply this left side by t plus 3 over t plus 3, right? And the right side, I multiply top and bottom by t plus h plus 3. There it is. T plus h plus 3 over t plus h plus 3. So I have a common denominator, and now I got a lot of distributive law, right? It's this trinomial, 3 terms, times this binomial. So I have 6 multiplications here, right? I have 2t times that, and then 2h times that, and then 1 times that, and that. So that's 6. Then I have 6 more here. 2t times t plus h plus 3, and then 1 times t plus h plus 3. All of that. So there's going to be 12 terms, 6 here and 6 here. Okay, so I'm going to write 2t times those two, 2h times these two, 1 times these two, and then all of that. Now, I'll trust your algebra is good. If I distribute all of this, I will have 6 terms that are all positive. Do you agree with that? 2t plus 1 times t plus h plus 3. Everything's positive. All of that will be positive. Now there's a minus, so now all 6 of those are going to be negative. Right? So when I distribute all of that, it'll be negative. Okay, here we go. I got to go back up, but this will be 2t squared plus 6t. 2t squared plus 6t. 2ht plus 6h. 2ht plus 6h. And then 1 times t plus 3, well, that's just t plus 3. Okay, so I'm done with that. They're all pluses. And now, like we said here, when I distribute this part, they're all negative, right? This is all positive, but the negative makes them all negative. So it's minus 2t squared minus 2th minus 6t. Minus 2t squared minus 2th minus 6t. And then multiplying by 1 is easy. 1 times that. It's just that, except again, they're all minuses. So it's minus t minus h minus 3. Minus t minus h minus 3. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. Very, very conveniently, a whole bunch of stuff cancels out. 2t squared cancels out. 6t cancels out. 2ht is the same as 2th. They cancel out. T minus t cancels out. 3's cancel out. How do you like that? So even though we had 12 terms, 10 of them cancel out. It looks like the only ones that don't cancel out are the ones that I have circled. 6h minus h, which is 5h. Okay, so I have 12 terms here. 10 of them cancel out. I just have 6h minus h, which is 5h. And now, yes, that h gets to cancel that h. So finally, I was able to cancel that h out. So the only thing I have on top is a 5. Limit h approaches 0 of 5 over t plus 3, t plus h plus 3. Again, don't multiply out the denominator. You usually don't want to. Finally, and notice I keep writing limit h approaches 0. Limit h approaches 0. You have to keep writing it. Now I can plug in 0 for which variable? For h. So put a 0 right there is t plus 3 times another t plus 3, which is t plus 3 squared. All right, so that's what's involved. And yeah, the last little minor detail, it says find f prime of a. Well, just change that to a. 5 over a plus 3 squared. Final answer. And that's about it for that one. Okay. So that was a pretty long one. But the next one I'm going to show you is even worse, I think. Okay. So now I'm going to go back to do 2.79. If it looks like I'm going out of order, I am, but I was trying to go by what I wanted to cover first. So I wanted to show you the square root one, and I wanted to show you a fraction one. So I want to go 9, which is a polynomial. Find the slope of the tangent of the curve y equals 3 plus 4x squared minus 2x cubed at the point where x equals a. B, find the equation of the tangent lines at the points 1, 5, and 2, 3. Skip C. Okay. Even if I don't say so, anytime you see that graphing calculator icon, automatically skip it. Okay. All right, so essentially the hard part is find a derivative. Okay, so 3 plus 4x squared minus 2x cubed. And yes, those of you who've had some calculus background, you really want to use the shortcut for this, and you want to say, I just want to put the answer down. I'm not going to allow it. Okay, I told Prasanna, he's not going to allow it either. You got to show me this stuff. Okay. Now, if you know the shortcut, you can use that as a double check. Okay, but not now. All right, so I have to use the limit definition. Okay, so throw it in me here. So limit h approaches 0, f of x plus h minus f of x all over h. Well, the over h is always very easy. The minus f of x is not too bad. you just copy the original in parentheses. So parentheses 3 plus 4x squared minus 2x cubed. Now the hard part. F of x plus h means erase that x, put parentheses x plus h. Erase that x, put parentheses x plus h. So here's what it looks like. 3 plus 4 parentheses x plus h squared minus 2 parentheses x plus h cubed. So all of this stuff right here, between the two brackets here, that's f of x plus h. Minus the original f of x all over h. Okay, now we've actually done that before, x plus h cubed. I'll go straight to the answer. You can work it out. You can work it out as x plus h squared, get that answer, and then times another x plus h. But here's what it comes out to be. Okay, so 3 plus 4, x plus h squared is x squared plus 2xh plus h squared. Minus 2, you can work it out. X plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed. Minus parentheses. So when you have minus parentheses, you just change signs, right? So minus 3 minus 4x squared plus 2x cubed. And more heavy-duty algebra. So leave the 3 alone, but this becomes 4x squared plus 8xh plus 4h squared. Then I distribute the negative 2. Negative 2x cubed minus 6x squared h minus 6xh squared minus 2h cubed. And just copy all these guys here. So I have this real long polynomial, but once again, a lot of stuff cancels out. Very nice. 3 minus 3 cancels out. 4x squared minus 4x squared cancels out. Negative 2x cubed plus 2x cubed cancels out. So what do I have left? I have that one, that one, that one, and that one. 1, 2, 3, 4 terms. What do all 4 of these terms have in common? They all have an h, which very conveniently is going to cancel the h in the bottom. That's almost always the way these problems work. They work out in that fashion. So limit h approaches 0. Keep writing it. Limit h approaches 0. Limit h approaches 0. Limit h approaches 0. If you don't write it, I can take off points. Okay, so h paren 8x plus 4h minus 6x squared minus 6xh minus 2h squared. Then you cancel the h's out. Perfect. Keep writing lim. So limit h approaches 0, 8x plus 4h minus 6x squared minus 6xh minus 2h squared. Okay. Now that I'm not dividing by 0, I can plug in 0 for h. So put a 0 here, here, and here. Plug it in for h, don't plug it in for x. So that's gone, that's gone, that's gone. So your derivative function is 8x minus 6x squared. So that's my derivative. The derivative of this function. And yes, those of you who know the shortcut, you could use the shortcut as a double check, but you can't use that primarily. I need to see all this stuff. Okay, so they asked for this, all this other stuff. So what do you get when you have a? Just plug in a. 8a minus 6a squared. Okay, then they say at the point 1, 5 and 2, negative 3. I'll just do 1, 5. 2, 3 works in a similar fashion. Okay, so I just plug in 1. Plug in 1 right there. Plug in 1 right there. You get 8 minus 6, which is 2. So the slope of the tangent line at 1, 5 is 2. You just plug in 1 here and a 1 here. Point slope form, y minus y1 equals m times x minus x1. Stop. Y minus 5 equals 2 times x minus 1. And that's about it. Okay, and one other one, just some verbiage. 13. If a ball is thrown into the air with a velocity of 40 feet per second, its height is given by y equals 40t minus 16t squared. Find the velocity when t equals 2. Okay, way back in section 1 when we were doing all those graphs, okay, we had tangent to the curve. Okay, one of the applications was that it also gives us the velocity. So velocity was, you might recall, instantaneous rate of change, right? Instantaneous speed. Okay? So for us, we now know that means derivative. So when asking for the velocity, it means find a derivative and plug in 2. Okay. So let me do this one, and then maybe I'll stop after that one. Okay, so y equals 40t minus 16t squared, velocity at t equals 2. Okay, so when it asks for the velocity, you're finding the derivative. So I find the derivative, and then I plug in 2. Okay, so y prime, that apostrophe means prime, limit h approaches 0. So f of t plus h. So put t plus h right there in place of t. Put t plus h right there in parentheses, parentheses, parentheses. So everything right here in brackets is f of t plus h. Minus the original function, 40t minus 16t squared, all over h. There's an h there, right there. Okay, so now it's just some algebra. So 40t plus 40h minus 16, square that, t plus h squared, t squared plus 2th plus h squared. Distribute the minus sign, minus 40t minus 16t squared. Okay, I'm going to distribute this. I reached the bottom of my paper, so I got to go back up. That's minus 16t squared minus 32th minus 16h squared. Everything else is the same. Okay, so I'll show you that right up here now. So limit as h approaches 0, 40t plus 40h minus 16t squared minus 32th minus 16h squared minus 40t plus 16t squared. These two cancel out. These two cancel out. So I have 1, 2, 3 terms that all have, guess what? They all have an h, recurring theme. So I factor out the h parentheses, 40 minus 32t minus 16h divided by h cancels out. The whole idea behind the game is you got to get that h to cancel. So by doing some algebra, you can cancel an h on the top with h on the bottom. Okay, so limit h approaches 0, 40 minus 32t minus 16h. Now I plug in h equals 0, so that's gone. So 40 minus 32t. So that's my derivative function or velocity function. And yes, those of you who know the shortcut, you can go straight to that. We'll all be able to do that in chapter 3, but you're not supposed to know that now. Okay, then they want the velocity at t equals 2. I just plug in 2. You want the velocity at t equals 7. I plug in 7. So you can plug in anything you want. So y prime of 2, that's the way we say it. Y prime of 2, plug in 2. 40 minus 32 times 2. 40 minus 64 is negative 24 feet per second. And negative means it's falling, so the object is falling. Positive means it's going up. So negative 24 feet per second means it's going down. So there we are for that. Okay, so those were some derivative problems. I'll stop right there. I'm pretty much done for today. And let me check the chat. There's nothing in the chat. Okay, so folks, yeah, I said I do have to finish early today, so I apologize for that. I don't think too many of you are disappointed that I'm finishing early. Okay, so I'm going to stop. We'll say that I probably won't get a chance to get the video out because I have to run all these errands until much later. Might even be tonight or maybe even tomorrow. So sorry about that, but that's the best I can do for now. Okay. All right, so try to get a start on some of those other derivative problems. Have a good afternoon, and we'll see you tomorrow, and we'll continue from here tomorrow. All right, so bye, everybody. Have a good day. See you later.